2 weeks ago, I did a poll on the channel and asked you what experiment to do. You chose the chemical garden experiment. Welcome to Cube Chemistry, where we will discuss all the elements of the periodic system and also do experiments. Now, what is the chemical garden experiment? Well, this experiment creates beautiful tree-like structures by mixing a special salt with a liquid, causing them to grow and form a chemical garden. Now, how do we do this? We will create this stunning chemical garden using cobalt chloride and sodium silicate. This experiment is not only visually spectacular, in my opinion, but also teaches us some cool chemistry concepts along the way. But before we get started, let's talk safety. Cobalt chloride and sodium silicate are both irritants, so it's important to protect yourself. Make sure you're wearing safety goggles and gloves and avoid any eye contact with your eyes and skin. If you do get any of these chemicals on your hands, rinse immediately with plenty of water, safety first, always. So, what do we need for this experiment? Well, I used 20 grams of sodium silicate, 0.3 grams of cobalt chloride, 60 milliliters of distilled water, and I tried to do something with zinc sulfate, but that didn't seem to be so successful. So, now that we get everything, let's get started. If you want to take this experiment to the next level, you can even make your own sodium silicate. It's simple. Dissolve 16 grams of sodium hydroxide, lye, we've seen this in a previous video, in 40 milliliters of water. Then add 24 grams of crushed silica gel beads. They look normally like this, you might have seen them before. And you might need to heat the solution gently to get everything to react. So now that we've created our own sodium silicate, let's move on with the chemical garden. First, we need to heat some distilled water, and you can do this on a stove or with a butane burner. Now, I decided to do this with my magnetic stirrer. We want the water to be hot, about 150 to 175 degrees Fahrenheit or 65 to 80 degrees Celsius, but not boiling. Be sure to handle the hot water with care. What we have now is some hot water, not very exciting, and since I didn't want to make tea, we will add 20 grams of sodium silicate to a small beaker or a glass bottle. Now we will slowly pour the hot distilled water and stir it with a glass rod until the solution is fully mixed. If you're handling the beaker, don't forget to use oven mitts or heat-resistant gloves. Now here comes the fun part. We need to add the cobalt chloride, iron sulfate, and the zinc sulfate into the sodium silicate solution. Now you can do this with tweezers or forceps, but I decided to just drop it from the weighing paper. Now I did this from pretty high altitude, so my salts didn't float. But if they do, gently push them down into the solution. And try not to stir too much because you want to let the reaction happen naturally and really slowly. Now, I used only cobalt chloride and a little bit of zinc sulfate because I didn't have iron sulfate. And the zinc sulfate didn't seem to react so much, so I only added a few drops of it. Once everything is in place, let the beaker sit undisturbed. Watch with me as the cobalt chloride reacts with the sodium silicate to form a beautiful outerworldly structure. A chemical garden. This is the result of a precipitation reaction, where the insoluble metal silicates form and grow, creating those amazing patterns. This looks pretty cool, right? But what is actually happening here? Well, as the cobalt chloride dissolves, it reacts with the sodium silicate, forming cobalt silicate, which creates a semi-permeable membrane. And this membrane pulls in silicate ions from the solution, causing the cobalt silicate to grow in these stunning tree-like structures. So, in order to make the video a little bit longer, I experimented a day later with some more sodium silicate and some other metals. The metals that I used in this experiment were copper sulfate, calcium sulfate, zinc sulfate, and a little bit of cobalt chloride. Well, watch again what happens. Here's the chemical formula. And there you have it. The ionic equation shows us exactly what is happening at a molecular level. When you're done, you can save the sodium silicate solution for future experiment, or you can dispose of it responsibly. If your local regulations allow, let the water evaporate and then dispose of the solid waste in a plastic container. That's all for today's experiment. If you enjoyed this, make sure to like and subscribe. And if you think I missed something, make sure to put it in the comments. Also, if you're trying this at home, let me know how it went in the comments. Now, this was it for this week. Make sure to fill in the poll for next week because we are going to do another element. Have a nice week.